excess reagent problem? Yeah, we're going to start a factor label comparing our two reactants. And so we're not going to worry about our products for right now. The one thing I am going to do is make a little note to myself over here. I'm going to get my masses, my molar masses all figured out. And I'll do the sodium phosphate. Phosphorus is 30.97. Oxygen 16 times 4. Okay, you got numbers for those?
What's the two ends?
1, 2.
Oh.
It's okay. We'll get you through this. So I've got 80.06. And down here, 22.99. $163.94. Sound like what you've got?
Yeah.
Okay. Piece of advice.
Yeah.
When you take a test or a quiz or something for me, please, over to the side, do your molar mass calculations. One of the things that does for me is it helps me identify your problems, and when I can do that, it also helps me give you partial credit, which is really nice. So, okay, now, we can pick either reactant to start with. It does not matter which reactant we start our first factor label with. I'm just going to go with the first one. Nice and easy. Ammonium nitrate. So I'm going to start with how many grams of ammonium nitrate? 30. So I'm taking my given from the problem, and I've got 30.0 grams. Ammonium nitrate is my given. What units, what chemical in the next box? Grams of ammonium nitrate to cancel. Okay. And what units in chemical up top? Moles. Because I'm starting out in grams, for any stoichiometrical conversion, if I start in grams, I have to go down through the valley of the moles and back up to the highlands of mass again. So we're going to convert into moles, moles of NH4NO3. Now we're ready to do a mole ratio to compare these things. So what units, what chemical down here? Yep. Right, moles of ammonium nitrate, because I still have to have something to cancel. Okay, units in chemical above that for my mole ratio.
Sodium phosphate. Oh.
Moles sodium phosphate. Okay, now, at this point I've got my mole ratio. I'm ready to go into grams of sodium phosphate. Units in chemical here. Moles sodium phosphate. Units in chemical up top to finish. Grams of sodium phosphate. Okay, let's plug in numbers. This is a mole ratio. So this is the what? The number with grams is going to be the molar mass. Okay. Well, we're going to keep setting it up. Don't worry, I'm going to work with you a little bit later, but let me run through the whole thing. We're saying that there are 80.6 grams of ammonium nitrate in 1 mole of ammonium nitrate, right? All right. Here we've got our mole ratio. Where do we get those numbers? The coefficients. So we have a 3 here, 3 moles of ammonium nitrate for every 1 mole of sodium phosphate. And then this is just another molar mass conversion. So we have 1 mole of sodium phosphate is how many grams of sodium phosphate? 163.94. Just our molar mass. Okay. So this is the same thing you've always done. This is just a stoichiometry conversion, gram to gram. So go ahead and when you've got a number for this, I don't know, cross your eyes. Okay. So I know a few of you have numbers for this. Yeah, don't cross them for too long, they might stick. Okay. So what'd you get?
20.4771421.
Perfect. 20.477142114 grams of sodium phosphate. Okay, this is easy, right? So for how many of you is setting up the factor label to compare them and getting a number pretty easy at this point? Yeah, I think for most of you that's not difficult. The challenge is what comes next, right? Doing something with that number. So I have a little cheater sheet here for you. I'm going to pass this out. Remember me talking about the sentence that you were going to write yesterday?
I have no idea what's going to be.
Okay, well, that's perfect. We're going to never get a limiting and excess problem wrong again. Every time we do one of these, we're going to do a factor label. You can just set it someplace if there's extras. Okay, every single time that we do a factor label for limiting and excess, we're going to write a sentence right after that. And the sentence is this: blank can react blank, however, we have blank. So this is 1, 2, 3. Therefore, we will either, there are two things that can happen. A, we will run out of blank, or B, we will have blank left over. So, the thing that goes in this first square is the given that you started that factor label with. So in this case, we're saying 30 grams of ammonium nitrate. Turn this a little bit. Okay. 30 grams of ammonium nitrate can react. Number 2 is the answer that you got in this factor label. So and here we can go to sig figs. Can react 20.5 grams sodium phosphate. So those are easy. However, we have, and number 3 is whatever chemical you named here, but the amount that you're given in the problem. So in the problem, how much sodium phosphate were we given? You have to go back to the 50 grams. However, we have 50 grams of sodium phosphate. Therefore, we will either run, are we going to run out of sodium phosphate, or will we have leftover sodium phosphate? We're going to have leftover sodium phosphate. We've got more sodium phosphate than we need. So the answer here then is the amount in number 3 minus the amount in number 2. Okay? So in this case, we're going to have what, 20.5, I'm sorry, 29.5 grams of sodium phosphate left over. Okay? Now, I'm going to say two more things. We got really lucky here. We don't have to do a second factor label for this. Why not?
Because it goes in grams and you end up with grams.
Well,
We
no,
got the excess. for
because
that.
we lucked out and we did the one that gave us an answer in the excess first. So we now know that the sodium phosphate is the excess and we know how much is left, which means which ones you're limiting. The other one, whatever's left. Yeah. If we had started off with the sodium phosphate and gotten our answer in ammonium nitrate, we would have had to do a second factor label to figure out how much we were going to have left over. Okay. I'll stop the video here. You're going to have the rest of the period to work on the practice problems. There will be a FIP quiz on Monday, Tuesday, FIP quiz on Tuesday, and I'm going to work with people individually who have questions.